Hello and welcome to all students. In this lecture, we learn about congruence relation on shade. Congruence relation on shade, and we study about some points. See the outline of our lecture. First of all, we see some introductory part. Then we see the definition of equivalence relation. Then we will see some propositions and their proofs. So here we know that the relation which is reflexive, symmetric and transitive, that relation is called as equivalence relation. And in the previous lecture we saw the congruence relation modulo n on the set of integers is also a reflexive, symmetric and transitive. Therefore, the relation of congruence relation modulo n on the set of integers z is also a reflexive, symmetric and transitive, and therefore this relation is also an equivalence relation on z. Now we see some propositions which are immediate consequence of the theorem which we have proved in the previous lecture. So let us see the proposition number 1. So this proposition says that if A is congruent to B mod n, then for all integers x, A plus x is also congruent to B plus x mod n, and A into x is congruent to B into x mod n. So see here, this proposition says that if A is congruent to B mod n, then A plus x is congruent to B plus x mod n, and A into x is congruent to B into n. So A into x is congruent to bx mod n. आता याच्यामध्ये बघा A इज कॉन्ग्रुएंट टू बी mod n, हे जे इक्वेशन आहे याच्यात तुम्ही कोणताही इंटिजर मिळवू शकता. x म्हणजे लेफ्ट हँड साईडला a प्लस एक्स, राईट हँड साईडला b प्लस एक्स. ओके, वी कॅन ॲड एनी इंटिजर्स और and the second result is ax is congruent to bx mod n, means we can multiply by any integer to this congruence relation. So this proposition is very much important. So while solving the problems we will use this proposition. So let us write the proof of this proposition as given that A is congruent to B mod n. This will imply that n will divides the difference A minus B. So this is by definition of congruence relation. So A is congruent to B mod n. This means n divides the difference A minus B. So this implies, now here in A minus B we subtract x and add x, so there will be no change. That is, n will divide A minus B minus x plus x, and that is n will divide A minus B minus x plus x. So just we remove the bracket, and then we put a bracket to the positive A and positive x, means this will implies n will divide A plus x minus B plus x. This implies that A plus x is congruent to B plus x mod n, means n divides the difference of A plus x and B plus x. Therefore A plus x will be congruent to B plus x mod n. Similarly, as A is congruent to B mod n, this implies that n will divide the difference A minus B. So this will implies n will also divide to a scalar multiple of A minus B. or integer multiple of a minus b. Therefore, this implies n will divide a into x minus b into x. So this implies, so here n divides the difference ax minus b. Therefore, ax is congruent to bx mod n. Therefore, ax is congruent to bx mod n. So while listening this lecture, we students have to be very careful and must have a keen observation, uh, step by step. While listening, you have to look toward the steps also. Okay, so don't listen only. So you have to look towards the steps. Now consider the proposition number 2. So in this proposition, proposition 2 states that if ax is congruent to bx mod n, and if the GCD of x and n is 1, the GCD of x and n is equal to 1, then a is congruent to b mod n. Means here, what we have given here, if a into x is congruent to b into x mod n, and if GCD of x and n is equal to 1, then a is congruent to b mod n. Means we can cancel the x, from the given congruence relation x congruent to b mod n, if and only if. कधी तुम्ही कॅन्सल करू शकता जर x आणि n चा GCD किती पाहिजे, 1 पाहिजे. x आणि n यांचा GCD 1 असेल तर या कॉन्ग्रुअन्स रिलेशनमधून तुम्ही x हा डायरेक्टली कॅन्सल करू शकता. So that is our proposition, and that is also very important. While solving problems, it will play very much important role. So write the proof of this proposition. Given that ax is congruent to bx mod n, so by definition of congruence relation, n will divide the difference ax minus bx. So see in the next step, n will divide the difference ax minus bx, and this implies n will divide a minus b into x. We are taking common, so a minus b into x. So as n divides the product, a minus b and product of a minus b and x, therefore, so either n will divide a minus b or n will divide x. Okay, एकतर n a minus b ला डिवाइड करेल किंवा n ला डिवाइड करेल. ओके, but given that the GCD of x and n is equal to 1, therefore n does not divides x. So this implies n must divides a minus b, and by definition, so as n divides the difference of a and b, therefore by definition of congruence relation, a must be congruent to b mod n, and this is our aim to show that. Okay, so in this way we can write the proof of this proposition. Now let us see the proposition number 3. Proposition number 3 says that if a is congruent to b mod n and c is congruent to d mod n, then we have the following. First thing says that a plus c is congruent to b plus d mod n. So first statement says that we can add the two congruence relations. We can make the addition of these two congruence relation. So A congruent to B mod n and C congruent to D mod n. These congruent relations we can add left hand side into left hand side and right hand side into right hand side. Means A plus C is congruent to B plus D mod n. So we will prove this property. Okay, secondly, this proposition says that A minus C is congruent to B minus D mod n. This second statement says that we can subtract the given two congruence relations. Means A is congruent to B mod n and C is congruent to D mod n. We can make the subtraction of these two congruent relations. Now third statement says that AC is congruent to BD mod n, BD mod n. Means this statement says that we can take a product of these two congruence relations also. Means uh, left hand side multiply with left hand side and right hand side multiplied with right hand side of this congruence relation. So AC is congruent to BD mod n. So now we will see the proof of all these three properties. So let us see the proof of first property. So here first property says that if A is congruent to B mod n and C is congruent to D mod n, then A plus C must be congruent to B plus D mod n. So let us prove this property. So as given that A is congruent to B mod n and C is congruent to D mod n, then by definition of congruence, this implies that n will divide the difference of A and B, and also n will divide the difference of C and D. So therefore what will happen, as n divides A and B, as n divides A minus B, therefore A minus B must be in the multiple of n. Similarly, as n divides C minus D, therefore C minus D must be in multiple of n. Therefore there exist two integers, say lambda 1 and lambda 2, such that A minus B is equal to lambda 1 times n and C minus D is equal to lambda 2 times n. Means A minus B is in multiple of n and C minus D is also in multiple of n. So in this first case, show that A plus C is congruent to B plus D mod n. Therefore we make the addition of these two equations. So now adding these two equations and see what we get. So this implies that A minus B plus C minus D is equal to lambda 1 n plus lambda 2 n. So लेफ्ट हँड साईडमध्ये ॲड करायची आहे आणि राईट हँड साईड ही राईट हँड साईडमध्ये ॲड करायची आहे. सो this is nothing but, so left hand side is as it is, we make the adjustment A plus C minus B plus D, and it is equal to, on the right hand side we take n common. So if I put lambda for lambda 1 plus lambda 2, then on the right hand side Now on the right hand side you will get lambda n. So this implies a plus c minus b plus d is equal to lambda times n, means the difference a plus c minus b plus d is in multiple of n, and this shows that n will divide a plus c minus b plus d. Therefore n divides a plus c minus b plus d. Therefore by definition of congruence relation we can write a plus c is congruent to b plus d mod n. Similarly, now we will prove the second property, which says that if a is congruent to b mod n and c is congruent to d mod n, then a minus c is congruent to b minus d mod n. So as given that a is congruent to b mod n and c is congruent to d mod n, by definition of congruence this implies that n will divide the difference a minus b, and n will also divide the difference c minus d. Therefore as n divides a minus b, therefore a minus b must be in the multiple of n, and c minus d will also be in the multiple of n. Therefore there exist two integers, say lambda 1 and lambda 2, such that a minus b can be written in the multiple of n, and c minus d can be written in the multiple of n. Therefore a minus b is equal to lambda 1 times n, and c minus d is equal to lambda 2 times n. Now subtracting these two equations, you will get this thing, means this equation. So subtract left hand side from left hand side and right hand side from right hand side for these two equations. So a minus b minus c minus d is equal to lambda 1 n minus lambda 2 n. So from the right hand side we take n common from the two terms, and on the left hand side we make the adjustment or we rearrange the term. Okay, so a minus c minus b minus d is equal to lambda 1 minus lambda 2 into n. So we see here, if I put lambda for lambda 1 minus lambda 2, then what we get is left hand side is as it is, and on the right hand side you will get lambda n. So this shows that difference of a minus c and b minus d is in the multiple of lambda, integer multiple of lambda, integer multiple of n. Therefore n divides the difference a minus c minus b minus d, and this implies that a minus c is congruent to b minus d. A minus c is congruent to b minus d mod n. So this is the second statement that we have proved. Now consider this third statement. Third statement says that if a is congruent to b mod n and c is congruent to d mod n, then ac is congruent to bd mod n. That we have to prove here. So how to prove? We will prove this statement step by step. By definition of congruence, we have n divides a minus b and n divides c minus d. Therefore, again there exist two integers lambda 1 and lambda 2 such that a minus b is equal to lambda 1 times n and c minus d is equal to lambda 2 times n. So we have equation 1 and equation 2. Now multiply to equation 1 by c and multiply to equation 2 by b. Then we have equation number 3 like this: AC minus BC is equal to lambda 1 into n into c, and we have next equation CD minus DB and is equal to lambda 2 into NB. This is our fourth equation. Now we adding equation 3 and equation 4 and see what do you get. So AC minus BC plus CB means BC, CB minus DB is equal to lambda 1 and C plus lambda 2 and C. AC minus BD is equal to lambda 1 into C plus lambda 2 into B, and n is common. So this says that n divides the difference AC minus BD, and this implies that AC is congruent to BD mod n. So in this way our lecture is over, and if you have any query in this lecture you can contact or you can ask. So now here we stop our lecture. Thank you very much.